How do people live their mobility sphere? What's their degree of exploration and what's their degree of routine? These are some of the fascinating questions me and my colleagues at Kdd Lab investigated during a collaboration with Filippo Simini and Albert-László Barabási in the context of the DataSim European project. The availability of big data on human mobility allowed us to observe the mobility, the displacement of about 100,000 individuals in a period of 3 months. Starting from this data, we computed for each individual her total mobility radius, that is the characteristic distance traveled by the individual in the period of observation. Then we compared her total mobility radius with the recurrent mobility radius, that is the mobility radius computed on a subset of preferred locations, for example, on the home and work location. We discovered that, quite surprisingly, people tend to split naturally into two well-separated groups, each with different characteristics. The first group consists of people for whom the recurrent mobility is very similar to the total mobility radius. In other words, the mobility of returners, as we named the individual in this profile, can be reduced to a subset of few preferred locations, home and workplace, for example. The other group of individuals consists of explorers, people whose recurrent mobility is only a small fraction of their total mobility. In contrast to returners, who show a sort of B-model mobility composed by home and work location, explorers show a star-like pattern, a star-like mobility pattern, with a central core of locations that are, for example, home and work locations, around which a set of other distant locations gravitate. These findings allowed us to develop a mathematical model to capture the returners and explorers dichotomy, improving existing models who are not able to detect this dichotomy. Moreover, we performed intensive experiments and computer simulations in order to understand the impact, the consequences of our findings. And we discovered that returners and explorers play different roles in the spreading of an epidemic on the territory with their movements. And also we discovered that there is a sort of social homophily, that is, explorers preferably communicate with other explorers. This research, published on the Nature Communication Journal, show us the power of big data in observing and understanding human behavior. That is another step toward the definition of more realistic simulations and in crucial fields like energy consumption, epidemics, urban planning.